Alright, in this video we're going to be looking at the lessons 8.1 to 8.3 quiz. So let's go ahead and see how you did on that. Starting with what is my first one, it says select any of the sequences below that represent a geometric sequence. So a geometric sequence, remember, is where you're multiplying by the same amount each time. And so, like for example, for the first one, if I wanted to see if that was a geometric sequence, I could take 42.5 and divide by the one before it, which is 50. And when I do that, I get 0.85. Well, if I take 35 divided by 42.5, I get 0.82. So we do not have the same ratio for that first one. So the first one is not a geometric sequence. The second one, I know that's not a geometric sequence because 1 divided by 0 would be undefined. You can't do that. So you can't even create a geometric sequence at all out of that second one. The third one, I could take 12 divided by 8. When I do that, I get 1.5. If I take 18 divided by 12, I also get 1.5. So that tells me, and if I took 27 divided by 18, then to confirm it, I would also get 1.5 there as well. So here we have a common ratio of 1.5. So that would be a geometric sequence. All right, so here we got to figure out, well, which ones of these are arithmetic sequences. So the first one, I see that if it's an arithmetic sequence, you'd be adding the same amount each time. And so here, going from 8 to 12, I would add 4, because 12 minus 8 is 4. But 18 minus 12 is 6. So this does not have a constant difference. Going from 0 to 1, I would add 1. From 1 to 3, I'd add 2. From 3 to 6, I'd add 3. And then from 6 to 10, I'd add 4. Well, even though it's a nice little pattern, it's not a common difference. And so it's not that one. So it could be this one, but let's see. So lastly, going from from 50 to 42.5, what's happening there is I'm subtracting 7.5. Well, if I take 42.5 and subtract 7.5 again, I get 35. And if I take 35 minus 7.5, guess what? I get 27.5. So that tells me that this last one is an arithmetic sequence. All right, so here they tell us this is a geometric sequence, and we want to find an explicit formula for that. Remember, an explicit formula for a geometric sequence would be g sub n equals our first term times a constant ratio, and then we'd have an exponent to the n minus 1 power. So I see that the first term is 32. So now I got to figure out, well, what am I multiplying each time by? And so going from 32 to 8 and from 8 to 2, you might say, well, you're dividing by 4. Well, we're putting what we're dividing by here. So multiplying by each time. So not what we're dividing by. So you want to put that in as 1/4. Or if you took 8 divided by 32 and found that your answer is 0.25, if you put 0.25 in there, that would also be the correct answer. All right, a car is purchased for $20,000. It depreciates and loses value by 12% each year. What is the value of the car after 10 years? All right, so this is an exponential function where our growth factor is, well, we're decreasing by 12%. So let's start out with the 20,000. So what I would do is I would take 100% minus 12, or 1 minus 0.12. Either way, I get 0.88. So that represents my growth factor. It's depreciating, so it should be, so it's losing value, so it should be between 0 and 1 there, which it is. And then we would have, what is the value of the car after 10 years? So then our exponent would be 10. So for this one, you just take, on your calculator, take 20,000 times 0.88 to the 10th power. And when you do that, you get $5,570 when you round to the nearest dollar amount. All right, let's look at the next one. The next one is for an arithmetic sequence. It says, consider that arithmetic sequence, write an explicit formula in simplified form. So remember, our formula for an arithmetic sequence, the explicit formula for an arithmetic sequence is this, where we take d times n minus 1 plus your first term. So the first thing we need to do is figure out, well, what's my constant difference? So knowing that this is an arithmetic sequence, it doesn't matter which ones I subtract. I could take 11.8 minus 10 and easily see that's 1.8, or take 10 minus 8.2 and get 1.8. Either case, we end up getting 1.8 as a constant difference. And then our first term is 8.2. So what I would do is I would distribute that 1.8 through, so I get 1.8n. But then I would have negative 1.8. When I multiply 1.8 times negative 1, I'd have negative 1.8. When I add that to 8.2, I get 6.4. So your equation in simplified form would be 1.8 times n plus 6.4. You can always test this out by putting like 2 in here for n. And when you do that, you'd get 3.6, and 3.6 plus 6.4 sure enough is 10. So you could do that with these different terms, putting in 1, 2, 3, 4 in for n, and just making sure we get those values in the sequence just to confirm that we have the correct equation. All right, here's another situation where it says after his first month of being in business, Adam has 42 clients. His goal is to add 20 new clients each month. So we want to write an explicit formula in simplified form for the sequence. So it doesn't tell us that this is an arithmetic sequence, but we can figure it out by the fact that we're adding 20 new patients each month. So that's our constant difference. So our constant difference, again, is 20 times n minus 1. And our first term would be after his first month, he has 42 clients. So it would be plus 42. So I could simplify this by distributing the 20 through. So we have 20n, and 20 times negative 1 is negative 20. But when I add that to 42, I get 22. So my explicit formula would be 20n plus 22. Now in part B, it says after 1 year, which is 12 months, how many clients should he expect to have? So again, you want to be careful because we're not going to put 1 in for n, because 1 would represent 1 month, because n is referring to the number of months here. So we would take 20 times 12 plus 22, and when you do that, you get 262 as your answer. Again, the way that we did that is you take just 20 times 12 plus 22. You put the number of months in for n. All right, let's look at number 7. So number 7, this is a geometric sequence, and we have the second term and the fourth term. We want to figure out what the third term is. So to find the third term with the middle term, when we're given two numbers in a geometric sequence and we're finding the one in between them, then what we do is we find the geometric mean for those two numbers, meaning we take 120 times 7,680 and take the square root of that product. So you can let your calculator do all the dirty work for you and just type that in. So just take the square root as 120 times 7,680. And when we do that, we get 960 is our third term. So now to figure out, now I'm going to do this in a different order. To find our constant ratio, or to get to the first term, we need to figure out what our constant ratio is. Because what we have now is we have 120 is our second term, and then we have 960 is our third term, and 7,680 is our fourth term. So to find the first term, I first need to figure out, well, what am I multiplying by each time? So if I take 960 divided by 120, we would get 8 as our answer. Or if I took 7,680 divided by 960, we would also get 8 as our answer. So our constant ratio here is 8. So to find out what the first term would be, I would go backwards. So if I took 120 divided by 8, that would give me 15 as my answer. So that means 15 would be my first term, because if we went through that and multiplied by 8 each time, 15 times 8 would be 120, and then 120 times 8 would be 960, and so on. All right, let's look at number 8 here. So it says, find the limits of each of the following. If a limit does not exist, respond with none. Okay, so for the first one, what we're going to do there is we have the limit, we have two pieces there. We would find the limit of both of them. So the limit of 8 as n approaches infinity, and the limit of 3 over 2n as n approaches infinity. So the limit of 8 is just 8, because if you were to just draw a line, that limit, it would just approach 8 as you approach infinity. The limit of 3 divided by 2n. Now, since our degree is bigger in the denominator than it is in the numerator, that means the limit of that would be 0. And 8 plus 0 would be 8. So the limit for letter A would be 8. Now for letter B, since the degree in the numerator and the degree in the denominator are the same, your limit is going to be the leading coefficients of the numerator and the denominator. So it'd be 3 in the numerator and 1 in the denominator. Well, 3 over 1 would just be 3. All right, so for the next one, we have 4n squared minus 8 over 5n to the 5th plus 3n. So the degree is smaller on top. So remember, whenever that happens, the limit would be 0. For letter D, it's the same problem, just been switched around. So in that case, if the degree is bigger on top than it is on the bottom, then that means there's no limit. So we would just type in none there for that last one. All right, so here they give us a recursive formula. And they say find the next three terms of the sequence. Now, something to make sure to point out here is the first term would be 9.5. And they already gave us that as 9.5, so we don't need to figure that out. So all I got to do is to find the next term in the sequence is just take and multiply 9.5 by 1.2. When we do that, we get 11.4. Then just keep doing that. So if I take 11.4 times 1.2, I get 13.68. And then if I take that times 1.2, I get 16.416. So those will be the next three terms of that sequence. Now if I said find the first three terms of the sequence, that would be a situation where I wouldn't even give you this first one. So you want to make sure that if this were the test, and if I ask for the first three terms, don't forget the obvious. The obvious is the fact that we have our first term is 9.5. All right, let's look at the last problem. So the last problem looks similar, but this time it's an arithmetic sequence. And so this time, again, we're starting with 9.5 as the first term. But then what we're doing is we're adding 1.25 each time. So the second term of the sequence would be 10.75. Then the next term would be 12, just 12 whole. And then the next term would be 13.25. And that's it. That's the last one in the quiz. So hopefully that answers the questions that you might have had from the quiz. And if you still had any of them that you weren't sure about or didn't quite understand what I did, please make sure you reach out to me so I can help you out with that before moving forward.